Now into the interesting case studies. The first compound is non-crystalline compound, a prodrug that breaks up into its parent in the intestine. The prodrug is a BCS3 compound, the parent is a BCS2. The API was susceptible to hydrolysis in acidic solution as well as in the solid state. The material, or the API, was amorphous. You can see from the hygroscopicity that the material was highly hygroscopic. In fact, it was gelling, and this led to a lack of disintegration and incomplete dissolution in the tablets. We're also dealing with very limited API, about 130 grams of material with a high dose strength, 150 milligrams, not compatible with basic excipients. And because it was degrading in the stomach, this led to the need for enteric coating to survive the stomach. And the previous CDMO that worked on this compound, the enteric coating was showing significant amounts of bearding. How did Crystal Pharmatech resolve these issues? We resolved them by completely understanding the molecule and dealing with the molecule properties. From a stability standpoint, we kept the API at 5 degrees, the drug product at 2560, manufactured at low relative humidity to avoid the hydrolysis, pack in a foil-to-foil blister, and monitor the hydrolysis even during dissolution. To minimize the gelling and the dissolution issues, we micronized the API, but then coated it with colloidal silicon dioxide to improve the disintegration, dissolution, and prevent the gelling. We used small amounts of API using the compaction simulator for the tablet development and understood that we needed to drop the outlet temperature to minimize the bearding. What you can see on the right here is this led to zero release in SGF, complete release of the API in the intestine and in facet media here, and the increase in coating slows down the dissolution rate. So what do I mean by understanding your molecule? Really understanding the target product profile parameters. What's your patient population, your treatment plan, your route of administration, but then also understanding the DMPK parameters. How does it metabolize? Does it have a significant amount of efflux? What type of permeability does it have? And then the molecular profiling of understanding accurate solubilities. This then leads directly into your medicine. With this good understanding of the material and the good understanding of the molecule, we can understand how these variables of the compound impact your target product profile. This leads to small number of prototype formulations really honed in on your molecule, minimizing the amount of API that you need and getting you to your CTM manufacturing faster with a higher probability of success.